Lesson 27 is called More on the Distributive Property and Simplifying Decimal Equations. So we have two parts in this lesson, and we're going to start with that distributive property part. The first problem says, use the distributive property to expand xy times y squared minus x squared z. Now if we remember the distributive property tells us we can multiply our outside term times each of the terms we have on the inside. They're going to be separated in this case by subtraction. So let's go ahead and do that. What we're going to do is we're going to say xy times y squared. Then we're going to subtract. We've got xy times x squared z. Now we need to simplify. We have x, y times y squared. That must give us y to the third power. So x times y to the third power minus, well, we've got x times y times x to the second power. That must be x to the third power. X to the third power y z. We go about using the distributive property to expand this or simplify this because it takes our three different terms that we originally had and combines them into two. It looks a little bit easier to solve. And we've got our final answer. If we knew what the value of the variables were, then we could evaluate, but we don't, so we leave our answer just like this. Let's go ahead and move on to the next problem. We want to use the distributive property to expand again. This time we've got our parentheses first and what we're multiplying by second, but we're going to do the problem the same way. Let's go ahead and let's take this term and we're going to multiply it in on the left first, and then we're going to multiply it in on the right second. So we're going to get 2x squared y, 2x squared y times ay minus, then we've got 2x squared y times 4y to the fifth power. And we can go ahead and solve. Well, I've got a 2x squared. You can see we have y times y. That must be y to the second power, a. Minus, we've got 2 times 4. We want to simplify whenever possible. 2 times 4 must be 8. X squared, because there's no more x terms anywhere. And y times y to the fifth must be y to the sixth. And we've got our final answer. We can't subtract these because this term is x squared y squared a, whereas this term is x squared y to the sixth. These are not like terms, so we leave our answer just as we see it here. Let's go ahead and look at our next example. This one is about simplifying problems with decimals. Now, if we have a problem like this, we're solving 0.002k or 2,000ths k plus 200ths is equal to 4 200ths. Well, what we want to do in this problem is to get rid of our decimal. And how we're going to do that is to multiply every term by 1,000. And I know I'm going to multiply by 1,000 because I want to take my smallest number and move it over into the ones place. So the first step here is to multiply each term by 1,000. So if we multiply 2,000ths by 1,000, we must get 2. So we're going to get 2k. Plus, if we multiply 200ths by 1,000, we must get 20. And if we multiply 4.02 by 1,000, we must get 4,020. Notice we move the decimal point 3 to the right each time. That's because we're multiplying by 1,000. Alright, now this problem is a lot more straightforward to solve. We're going to go ahead and find out what k is. So if we want to do that, we need to isolate the k. We're going to undo the addition of 20 by subtracting 20 on both sides. We're going to get 2k is equal to, well, 4,020 minus 20 must be 4,000. Now we're going to divide by 2 to undo the multiplication of 2 times k, because we just want k. We're going to divide by 2. Half of 4,000 is 2,000, so k is equal to 2,000. When we have a problem like this, turning all these decimals into whole numbers makes it really easy to solve, rather than working with the decimals and then dividing by a decimal in the end. But if you did that, you get the same answer. This was just a little bit easier. K is equal to 2,000, and we're all done. We'll practice these concepts on our next lesson practice, page 114 to 115 during our next class. Make sure you've got your notes completed, and have a nice afternoon.